Right then, take two. Hopefully it's recording sound this time. When you click the link, it will bring you to this page. There are 4 different simulations. We will use these ones at some point, but for the time being, just ignore them unless you want to go in and have a bit of a play later on. This is the one I want you to look at today, and that says Net Force. So click on that, and it's just a little tug-of-war game. We've got people of different sizes, and you can attach them in different ways to do a bit of a tug-of-war game. Before you start, you might want to mute this so it looks like that. When the cart gets to one end, you get a little celebration for whichever team wins. It's cute the first couple of times, it gets less cute. What you do need to do is tick these 3 boxes so you can actually see what's going on. And first one, I'm just going to attach one person on the left. So when we've got one person pulling on the left hand side, we get a resultant force equal to the force that they are applying. Because it's got wheels and because we're not really thinking about things like friction and air resistance and drag and all that, all that's being applied is that one force. So we don't worry about friction in this sort of simple setup. By default, it's paused until you press go, so I can attach people and I don't immediately see it pulling either way. So when I press go, it's going to start the simulation, and you'll see the system starts moving to the left and the speed's increasing the whole time. So you see the little dial turning around, speed increases until it gets to one end. That makes sense because you've just been reading the PowerPoint about Newton's first law. If we have a resultant force, the motion of the trolley changes. We've got a resultant force, a sum of forces of 50 newtons to the left. It started off stationary, started off with a 0 speed, 0 velocity in this case. And because there was a resultant force, the speed increased, it accelerated to the left. If I change the situation, by the way, it doesn't matter where you put these people, as long as they're on opposite sides. I don't think, you can't put a red onto the left hand side or anything like that. If I set it up with the same force on both sides, so 50 newtons left and 50 newtons right, and press go, I've got no resultant force, so there is no change in the motion. No change in speed. 0 resultant force, 0 change. I can do that a little differently. So instead of having one person applying a force to the left the entire time, or having 2 people applying a force in both directions the entire time, I can start off with a force pulling to the left. See the speed increase. If I attach this person partway through, it keeps moving to the left, but this person being added has stopped the initial increase in speed. That speed is still there, it doesn't start disappearing, it doesn't increase in speed and then go back down again. It just stays the same because, let's run that again, because there is 0 resultant force now. When I add this person pulling to the right, it cancels out the force going to the left. So we've got 0 resultant force, the sum of the forces is 0, so the speed stays the same. Have a bit of a play with it, see if you can do some interesting things. For instance, you can put a person going that way, see if you can slow it down to nothing, and then get it to go the other way. Sorry, the dog just farted. I wonder if that came through on the mic. Yes. Please keep having a go with it. Yes, I know. I'll take you out in a sec. Sorry about this. Have a go with it. See if you can get interesting things to happen. As I say, you can get it going left, then right, then left, then right, then left, then right. Depending on how many people you add to each different side. See if you can get it to stop. Oh, there we go. Yeah, so have a bit of a play.